Welcome back to geometry class. This time we'll talk about properties of isosceles and equilateral triangles. Yeah? So in this lesson, we'll use the facts that we know about isosceles and equilateral triangles to solve for missing sides and angles. Yeah? Let's recall a few things about isosceles triangles and equilateral triangles. First, what do we know about an isosceles triangle? Yeah? An isosceles triangle is a triangle with two congruent sides and two congruent angles. Yeah? Like in this picture. Yeah? Two congruent sides, two congruent angles. Next, what we remember about equilateral triangle. Equilateral triangle is a triangle with all angles congruent and all sides congruent. Yeah? And the each angle of an equilateral triangle equals 60 degrees. Good. And now we have two theorems related to isosceles triangles. First, base angle theorem. Yeah? So, if two sides of a triangle are congruent, then the base angles of the triangle are also congruent. Now, what does base angles mean? Base angles usually they are located at the end of the congruent segments. In this case, base angles are B and C. As you can see, angles B and C both are at the end of the congruent sides. Yeah? So both are at the end of the congruent sides. Those angles are called base angles, and they are congruent. Good. Next. We have a converse to the base angles theorem. Let's recall something about converse. Remember, converse is written by switching the place of hypothesis and conclusion. Yeah? Remember, the initial statement, the initial theorem was if two sides of a triangle are congruent, then the base angles are also congruent. Yeah. So what is converse? So we switch the place of the hypothesis and conclusion. So the converse would be if the base angles of a triangle are congruent, then the two sides of the triangle are congruent. Yeah? Look. Yeah? If two angles in the triangle are congruent, then the triangle is an isosceles triangle, which means two sides are congruent. Yeah? Good. Now let's have a few applications. Good. Look, find the value of x if triangle JKL is isosceles. Yeah? Now, we have these two sides, yeah? And they are congruent. How we know? We know because these two angles are base angles. Why? Because both are located at the end of these two sides. Yeah? So these are called base angles. Yeah? So we know these two sides are congruent or equal. Now, it says find the value of x. To find the value of x, we need to set up an equation. What's the equation? Of course, is 5x plus 5 equals 35. Let's write the equation. And we simply solve for x. First, we get rid of 5. We subtract 5 on both sides. Yeah? And we bring down 5x. 5x, negative 5x cancel out. And on the right side, you're going to have 35 minus 5 equals 30. Next, we divide by 5, yeah, because we need to get x alone. 5 and 5 divide out. So remain x equals 30 divided by 5 equals 6. So x equals 6. And of course, these sides, because it's congruent to 35, would be 35, yeah? And we can check. If you replace x with 6 here, you're going to have 5 times 6 equals 30 plus 5 equals 35. We are good. Good. Next. This time we have another isosceles triangles, but this time the sides are given, yeah, they are congruent, and according to the converse of the isosceles triangles theorem, if two sides of a triangle are congruent, automatically the base angles, yeah, are congruent, means equal, right? So we have to write the equation, these two angles are congruent, yeah? So the equation would be 9x equals 72. Yeah? We solve for x. We get rid of 9 by dividing by 9. Yeah? 9 and 9 divide out. X would be 72 divided by 9, which is 8. Good. Let's have an example with equilateral triangles. Two examples. Yeah? Look here. Find the value of x. We know triangle LKM is equilateral. In the same time, triangle LKM is equiangular, right? Measure of angle K, yeah, equals measure of angle L equals measure of angle M, yeah, and equals 60, right? So we need to find x. Now, the measure of angle L is in the same time 60 and 2x plus 32. Yeah? So we can write the equation. The equation would be 2x plus 32 equals 60. And it is a two-step equation. First, we get rid of 32 by subtracting 32. Yeah? Then we bring down to x. 32 and negative 32 cancel out. 60 minus 32 equals 28. Now we get rid of 2 by dividing by 2, both sides. Yeah? And 2 and 2 divide out. X would be equals to 14. Yeah? Good. And one more example. Next, find the value of y. Yes, this time the variable is y, and the length of ON. We know triangle NPO. NPO is equiangular and in the same time is equilateral. Yeah? Good. Now, how we find y? We know this triangle is equilateral, which means all of its sides are congruent. Now, because the length of this side is 5y minus 6, and the length of the other side is 4y plus 12, all we need to do is to make them equal, yeah, and solve for y. So, let's do that. 5y minus 6 equals 4y plus 12. Yeah? First, we have to combine like terms. How we combine like terms? By collecting y terms on one side. Yeah? On which side? So, we combine y terms on the left side. Why? Because the coefficient of this term, which is 4, is less than the coefficient of this term. Yeah? We bring the less term to the larger term. Yeah? So how we do that? By subtracting 4y on both sides. Good. Now, we start combining. So we keep the variable, and then we subtract coefficients. 5 minus 4 equals 1. Yeah? But usually we don't put 1 times y. Yeah? Now, you bring down negative 6. Then equals. These two terms cancel out. Yeah? What's left? 12. We bring it down. Then we get rid of negative 6 by adding 6 on both sides. Good. Negative 6 plus 6 cancel out. What's left? Y equals, and we simply add these numbers. 12 plus 6 equals 18. And we found y. Now, but we are not done. What it says here? Find the length of ON. So we have to plug it in. We know y equals 18. We simply, let's say, plug it in here or there, doesn't matter. But I think here it's easier because we deal with addition. Yeah. So 4 times 18 plus 12. Yeah. So 4 times 18 equals 72 plus 12 would be 84. Yeah. So for today is all we have. Yeah. Thank you. See you next time.